This video is going to take us through a new type of graph called an absolute value function. So we're dealing with things where we have y equals an absolute value with an x on the inside. And this is kind of a big topic for us because it leads into like all the new types of graphs we're going to do this year use similar rules to what we're going to learn related to absolute values. This graph right here, y equals absolute value of x, is called a parent function. It's called a parent function because it's kind of the most basic absolute value graph we can make. So if we were to do something like y equals the absolute value of x minus 2, or maybe y equals negative 3 times the absolute value of x, these red graphs right here, red equations, could be considered children of this guy because they're kind of just like variations on this. If we know what the black graph looks like, we can figure out what these red graphs are going to look like by applying some rules. So it's always good when we start with a new type of graph to figure out what the parent function looks like. And then we'll learn little tricks and shortcuts to graph other things like those red ones I had. So, anytime you are asked to graph something brand new, remember what we did with lines. Even though a lot of you guys knew y equals mx plus b already, I still made us make some tables. Tables are a great way to see how something new that you've never graphed before is going to look. So I'm going to make myself a little table right here. And I'm going to plug in x's, and I'm going to plug in y's. When you plug in numbers, you're allowed to plug in whatever you want. So I can choose 0, 1, 2, and I'll do 3 as well. And let's start there. So if you plug in a 0 here, you get the absolute value of 0, which is just 0. So 0, comma 0 is on my graph. If you plug in a 1, absolute value of 1 is just 1, so you get out a 1. If you plug in a 2, you get y equals the absolute value of 2, which is 2. 3, you get out a 3. So it seems like this graph right here is just going to be a line like this. It keeps going on up in that direction. Now, you might think, well, it's going to keep doing it in this direction too, because that's what the pattern seems to be here. But let's plug in a negative 1 and see what happens. If I plug in a negative 1, I get y equals the absolute value of negative 1. But the absolute value of negative 1 is actually a positive 1. So negative 1 comma positive 1 is on the graph. If you plug in a negative 2, absolute value of negative 2 is also a positive 2. So this graph isn't a straight line. It's actually a V. So it's all the positive parts are here, and it's got the negative parts that are increasing as well. So it should look symmetric. Same thing on both sides of these lines right here. And it makes a V. Easy way to remember that, because kids will forget later on in the year what type of graph this is. Think about an absolute value, really emphasizing that V. Absolute value graphs will always make some form of a V.